afternoon, guys. I am not feeling that well.
Aw.
Yes. I think it happened a couple weeks ago, and I'm pretty sure I know what the culprit is. I think it's the pineapple drinks that I have in my fridge. Yeah. So, yeah, I threw up during first lunch, then I took a nap, and I'm feeling a little better. So, yeah, it's
Sad.
So I was unable to do any work at all during my planning period. I just realized that that this particular chapter I haven't actually taught in 2 years because I had stuck it at the end of the AP1 a couple years ago, but I took it off for last year and realized that I didn't have a quiz ready for this particular lesson right off the bat. So yeah, that was fun to realize 5 minutes ago when I was trying to load it up into Focus. So we'll just see what happens today. The lesson thankfully isn't that complex, but I'll still check notes. So if you have notes out from our C 3.1, talking about 2D waves, intensity and reflection, I'll check those, and then I'm not sure if I'll make it to open house tonight. But there is open house tonight, 6 o'clock. Yeah, so checking notes. That's what I'm doing right now.
I haven't done it in like 6 years since I threw up.
Yeah, me too.
It's been like a month or two for me.
Yeah.
I don't remember that. I don't think I've ever thrown up, but I came close after practice once for swim. I don't know. Horrible feeling.
If it goes quick, it's all terrible. The anticipation is the worst part.
It's like that taste is just so nasty, like in your mouth. I hate doing it.
Sometimes, like, when it won't stop,
Like, you
it
try
feels,
to-
feels like your freaking organs are about to like come out.
It's like whenever I feel myself at the throw, I just like force myself not to.
Force?
No, yeah, I just like.
Nah, if I'm in the right place, like if I'm like at home, I don't know, just like I'm sick, I'm gonna let that happen.
It's like, do they say like it makes you feel better after? But I don't even care, bro. I'm not.
No, it makes me feel better, but I have to go brush my teeth. Bro, we just needed 3 to pass the IB exam.
If you have
3 or
your
4.
signed lab safety contracts, feel free to drop it in the inbox there. Thank you.
Signed lab.
Did you do it?
I swear they're due today. I'm not being I swear they're due.
Does he still give class note every grade?
Yeah. For in class and
I haven't even been showing them that. I couldn't even get extra points. I did some class notes.
I mean, you only missed one. Really one.
Yeah.
That's it. Probably won't take that one though.
We do some of this class. In my I just do anything that's because I mean, like,
Is that your notebook? What's a sketchbook?
when it's like,
Let's go.
when I get bored, I just.
Why does the guy have thug life on it?
No, because really like that.
It's not 21, bro. Dude, environmental science is so easy.
I know.
It's not even like we do work. It's just like we go. Yeah, we just go in there and do nothing. She said it's a 2-year course back
Maybe
into
if he's
one.
not feeling good, maybe he'll quickly teach it and we can make our flag.
That's a good idea.
He's not gonna be here open house.
But I think she's trying to get through it as fast as possible. I forgot everything we learned last year. So low key, I just need to learn most of the things this year. Get a 4. Good thing about IB's pass fail, bro. Pass fail.
I don't like that. It's like, I don't know, I don't care that much no more. Once I realize that I get to go here and get bright futures either way.
Oh, you have it either way.
Yeah, I realize that like,
Oh yeah, you do get it either way. What? You need just what? 3.0? 3.5?
3.5 weighted,
4.5 weighted?
3.5.
Oh, weighted 3.5.
Yeah.
Everybody's getting that.
Yeah,
I thought it was like 3.5
but
unweighted.
you need a 1340 on your SAT or something.
Okay, yeah. Do you have to apply? Or do you just automatically get it?
You automatically get it. Well, like, I think you have to like, well, if you have the qualifications, you just apply and then you get it.
I could probably just do it in like 30 minutes.
The only thing I don't have is the hours, but you can use paid work hours, and I have paid.
Yeah.
But I need the volunteer hours to graduate.
Yeah, you need 75 to graduate.
Yeah, but you can only use volunteer hours for graduation, but I have not done like, any volunteer. And I've done some and I haven't documented it. I just forget to do it.
Hardest thing about volunteering hours is not school activity, it's getting the signature. Because honestly, if you don't get the signature the same day, that's when it's really hard to get.
Dude, I got a signature a year after I did something in GRTC. It was the Veterans Day Parade.
How many hours do you get for that?
5.
Did you go to the GCLC camp?
See, I wish I
When
was.
I signed up,
You get like all your hours. You can go to.
75.
It's like a week. It's like an overnight camp, right? Like you go for a week.
5 days, yeah.
Yeah. You get all your hours. I should. If I was in JRTC last year, I would do it.
I've done it 2 times. So I'm gonna get
See, I don't like that, bro.
150 hours.
What happened is last year, so many people wanted to go. Thing is, they picked everybody who already went.
This year, actually, I really want to do JCLC, but I want to do the part where they just do paperwork, so nobody else has to do it. That's the work. You don't have your phone, you don't have any music, you're just doing paperwork for the entire time.
You don't want to do that.
I'm gonna do that.
Oh wait, yeah. So you're not allowed to have your phone at the camp.
Yeah, they take it, apparently.
But I want to do that to get 75 hours, but to also spare somebody from doing paperwork for 5 days straight.
If you need to get community service, do you have your own card?
Yeah.
Bro, like that on that TV's page, they post so much.
Yeah, no, I did. I signed up for this like.
You set up for the beach cleanup. That's a big one.
I haven't done that one. The beach cleanup's in like 2 hours though. I think. They had this all-day thing. It was just like special needs pickleball game.
Also, if you like, I know Miss Williams. If you ask Miss, like, I remember Miss Williams. She used to like, if you clean up her classroom after school, she'll give you volunteer hours. So you just ask any of your chill teachers, and they give you some.
Oh, really?
Yeah, like I remember Mr. Rains. He told me like, yo, bro. He told our class if you ever need volunteer hours, my class is hella unorganized. You come after school and I'll give you like, you can do like 1 hour, but I'll give you 10. But I don't know if he'll do that this year. But like, you can find a super chill teacher like who really doesn't care.
They haven't been giving me mine for months. I've been doing like the flag parade for like 3 years and they haven't given me once.
Oh, international fair.
Yeah.
What do you do? You just hold the flag and walk?
It's like 5 minutes.
International fair. That's another one. Yeah, that gives a lot of volunteer hours.
I kind of want to do a booth this year. I've been doing the flag parade every year, but I kind of want to do a booth.
Also, you
I
can
don't know what I
do.
would do though.
You can do a school showcase that they have here at Paxton. That can get a lot.
They let you do anything. It doesn't matter where you're from either. So I could do like China. I wanted to. I just had to do my research.
Are you taking Chinese?
You said what?
Are you taking Chinese?
I'm the TA for Miss Lee. Gaijin. You know what that means.
Oh, they all individually fell.
Yeah.
Not like the entire thing. But
Gaijin.
it was good while it lasted.
Well, they are
Gaijin.
particularly
Li
old.
Lao Xi.
Apparently,
Gaijin.
the screens were, they had
What, bitch?
they had reached their peak and just
19.
par for the course today.
He's actually 15.
All right, I'm gonna try to make this short and sweet, y'all.
I gotta say goodbye to her now.
You know how it is.
Yeah. You gotta say that.
So this particular lesson is kind of like a combination of two-dimensional waves and one-dimensional waves. But the whole chapter here is like learning different things about waves, like how reflection happens, but not necessarily just with light. So like reflection can happen with waves on a string, with waves in the water and things like that. So jumping into the 2D waves first, imagine you stick your finger up and down in a pond and it makes waves. Okay, so if you do it once, there's the initial point source of wave, and it just sends one wave front out and it expands, has a certain speed. Remember, the speed of the waves depends on the medium. Okay, so if we're talking about water waves, the density, temperature of the water is going to affect the speed of those waves. Remember that the source provides things like amplitude and frequency and wavelength in terms of the properties of waves. But the speed, even though the speed of the wave does include the frequency and the wavelength, the speed itself depends on the medium, the frequency and the wavelength depend on the source of the wave itself. So going back to the whole, let's make circular waves in the water. It's going to kind of look like the picture that you see on page 351. So we've got, and it also kind of looks like what we did with the Doppler effect. I kind of used the water wave as a diving board, if you would, to talk about the Doppler effect and how if we see these sound waves, the sound waves would look kind of like the water waves are as they spread out and stuff. And we saw with the Doppler effect how if we were to, if the source of waves or the observer were moving with respect to each other, then the waves would bunch up and we would experience a higher frequency as the source of the waves are coming towards us, or as it goes away from us, we would experience a lower frequency. So the same thing happens with other types of waves as well. Not just with sound, but it works with light. We talked about light last year as well, but other things like water waves too. So a really particular cool thing about the wave fronts of the water waves is that as they spread out, they're still circular, but imagine you do this like at the middle of the pond, right? And then your friend is on the shore, you know, a good quarter of a mile away or so, and at the shoreline, your friend sees wave fronts that are coming in like parallel lines, okay? Which technically, if we were to zoom out, okay, if we took a drone and we zoomed out and we looked at the pond as a whole, it would still be circular wave fronts. But zoomed into a particular perspective, these look like parallel lines. These are just these same things, just all spread out. Kind of like the whole, okay, well, assuming that the Earth is round, a globe, ballish type sphere, almost a sphere. It's not actually a perfect sphere because it's a little squished. It's actually wider if you measure the radius from the center of the Earth to the equator and compare that to the center of the Earth to the poles. The equatorial radius is actually a bit larger than the polar radius, because it's a bit squished, okay? Not a whole lot, I mean, it's definitely not something that if you were to go out in space and see it, it doesn't look like it's squished. But if you were to measure, it is slightly different.
How did
But
that know?
mostly it's spherical. But I don't know why I went there. But the whole like, well, if we just look at the ground, you know, people could say that the Earth is flat because you don't see the curvature until you zoom out. Okay, kind of the same approach that this is, but it's interesting that if we're far away from a point source, then the wavefronts are going to come in like parallel lines. We have the ray. The rays that go outward from the source, these rays have to be perpendicular to all of these wave fronts. So as we look at these waves coming into shore, these waves will also be perpendicular to those wave fronts. Just the reminder, the wave front acts like a crest of a wave. So like the water, the wave front, the crest, that would be like the top part of the wave, and then you have a trough, which is your low part, underneath the typical surface of the water, because the wave will displace the water as it goes through it. So if this is a crest, and then this is a crest, then we know that this is going to be a wavelength. We can measure what that length is, and as it expands, the wavelength shouldn't change as it, expands out. The amplitude will though, okay? The amplitude, how high the waves are, at the beginning, they're going to be the maximum height, but all of that energy gets spread out as this expands in a circle. It greatly reduces by the time you get to the shoreline. The waves are pretty small. So there's some cool conceptual questions that relate to that. Remember that our pods are going to be in the blue boxes in the books, and they will match with the page numbers associated with the lesson, which of course that's found in the homework schedule. Clean up on aisle 4. ATAs, can you get me some paper towels here?
Bro, bad days are the worst. It's like one bad thing after another, bro. Like, that's what I'm saying.
Actually, I've
It'd
got
be
some
like that.
real towels back in my closet.
She's not supposed to.
Like, especially like when you're sick, cause like everything goes wrong when you're sick, cause like you're already like weak.
Bro, he messed up his focus.
You know what I'm saying? One time I was sick, bro. I spilled milk all over my desk in my room too, bro. And I was just like, bro, this shit's over. And cause under my desk I have like a carpet. It's worse.
It's bad, bro.
It's worse. There's always like something. Bad days just turn into like ripple effects, bro. And we're learning about waves. It's a ripple effect. I'm telling you.
The irony, bro, the irony.
Telling you. It's all planned by the Illuminati.
I've got a couple of
I wonder how we do
First computer, we're gonna upload the footage. And then that thing broke. That
It's all
day.
a ripple effect, bro. And we're learning about waves. It's not a coincidence.
It's not.
This is all just his plan to teach us about waves.
Pardon me while I take care of
It's
myself.
really just planned like that.
That's a good joke. It's a ripple effect, guys. That relates back to the lesson.
I don't think he'd appreciate our joke.
No. Because then he's gonna remember everything that happened. Hopefully he doesn't put it together.
He makes the place extra hard.
Just for that, you all get a zero.
Just cancel the lesson for today. Honestly, just let us make our flags. Oh, Andy's open house. Shit. Bad day.
We'll just bring it over here since there's no people sitting.
And his chair got wet.
I have a towel for swimming. I don't know if you can use that.
I don't know, he's towels. I don't know what's wet though.
Some papers.
Oh, and more papers. Yeah, he needs to dry them.
Why does it always happen on like the bad days too though?
I know, like, bro, like, I wake up and I would stub my toe, bro. Like, a sick day.
Literally about to crash out.
What the hell? Nah, I swear, this class, it's always the most distracting thing to happen. Last year, oh my god, bro, it was bad.
It'd be like 30 minutes of actual teaching and the rest is just talking.
Yeah, like in the middle, like we'll be talking about some sort of like analogy in real life that has to do with physics, and then we'll start talking about the IB diploma. I'm like, bro.
What? He has a towel.
He's a what?
He has a towel.
Yeah, he does.
Yeah, I could definitely borrow it. I could borrow it myself.
I don't know, like I think he held onto the lid.
I think that's what he usually does. I mean, it is kind of awkward, like.
But no, the lid wasn't on. Like I saw the lid, I was like, why is he grabbing him by the lid? It's weird.
Maybe he's just weak from being sick.
Yeah. I'm getting checked out too at 2 to go to a dentist appointment. Listen to the lesson.
Are you gonna get cavities?
Oh, do you drive?
Yeah, yeah.
I think I think that's somebody else. That's one vaccine, I know who that is.
Say your joke.
What?
It's a ripple effect.
Oh, yeah.
Oh, I forgot my dad joke. It's not my joke. Actually, I think I forgot my dad joke.
It's not my joke. You're not giving me a 0.
No, he.
I can't have a 0.
Dad joke for today. Because we definitely need a bit of a laugh here. How many rebels does it take to transmit stolen Death Star plans?
How
How many
many?
rebels does it take to transmit stolen Death Star plans?
Only one Kenobi.
Oh.
One indoor, two.
Oh, yeah. See, at least I get this one.
Yes. If you've never seen Rogue One, one of the people that is responsible for stealing the Death Star plans and uploading it to the other rebel spaceships, which is what Princess Leia intercepts and puts in R2 at the beginning of the first movie. Andor is one of the characters that does that. Andor doubles. Okay. Moving on.
I've never watched.
Let's see. It mentions briefly about transmission, absorption, and scattering. We'll actually talk more about that in future lessons as it pertains to different types of waves and different things. So just a brief intro here. It does include intensity. So let's real quick talk about that real quick. So the intensity of our waves, and I'm pretty sure this is in the booklet, even though there's not a symbol on it. The intensity is equal to the power divided by the area. Yeah, it says that we talk about it more in V1. But we also know that that intensity is proportional to the amplitude squared. So this is a power and area, as in like if we talk about light, okay, and we've got a light bulb here, and how intense or how bright the light bulb is really depends on how far away from that light bulb that we are, right? Like if it's nighttime and we're trying to read a book, the closer we get to that lamp, that light bulb, the brighter the pages are and the easier it is to read my book. But the further away we are, the less bright, the less intense. This actually comes from the fact that as the light spreads out, it spreads out in a spherical form, as in the area, if we were to break it down as 4 pi r squared, which would be the surface area of the sphere. Okay, so imagine the energy of the light bulb spreading out in 3-dimensional space like a sphere, and all of the energy that it produces, it spreads out as the light travels. Okay, now we know that light travels fairly darn quickly, but there is the whole intensity is inversely proportional to the square of the distance. As in, if I were to be a certain distance away from my light bulb, I measure its intensity or its brightness, and then I double my distance. Now, my intensity that I experience is now 1/4 that which was before. Okay, so it goes based off of the inverse square. Now, the power here, the power is actually inherent of the source itself, like a 100-watt light bulb, for example. It's going to have a particular emitting a certain amount of energy per second. We know that, of course, the power is equal to the energy over time. So the power doesn't change based on how far away we are. That's based on the source of the wave, or the light bulb in this particular case. But the intensity is going to take that power output and divide it, again, as it spreads out over 3D space, then the intensity drops as we get further away from it. So now, this is going to be the amplitude, okay? So like, if we were to measure like the amplitude of those light waves, let's say, or the amplitude of like a wave in water. So the intensity of it, or how much power it can produce once it actually gets to you, is based on the square of the amplitude. So that A is different than that A. And then they also kind of spell out what this is in terms of the intensity is also inversely proportional to the square of our distance, which just comes from that equation, which I kind of broke down to you as well. There's some cool graphs on page 353 showing you the whole inverse square graph. It kind of looks like an inverse function, but it hugs into the origin more than just the 1/x type graph. Okay, so that's the second part. That's 4 through 9. There's a good chance your pod say 1 through 13, but I'm going to cut that down. Okay, you guys don't have to do all that. I'm gonna do like, the odds or something. Probably, because that's the easiest one without me actually going through and reading through them. And at this point in the day, I'm just gonna say odds. Last but not least, we have going back to waves on a string. We've got the reflection. We might have actually talked about that a little bit last, whenever it was last year. But this begins to talk about how waves act at a boundary. Okay, and we'll kind of sit on that major topic for the next few lessons as waves enter some pretty interesting things, and they do things like diffraction, which is what we'll spend a considerable amount of time on, specifically light diffraction. But other kinds of waves can do diffraction as well. always do the fractions. It's just a matter of how big the wavelength is and how small the hole is. But to kind of review, and again, they've got some good pictures on page 355 of our book, that as we have a wave on a string, it goes into a boundary, like if we're going from a light string to a heavy string, it's going to, so part of it's going to be transmitted, part of it's going to be reflected based on the nature of what comes first, like lighter versus heavier or heavier versus lighter. Then different things happen, but it tells you real good in the book. As we kind of look at, okay, well, how do two-dimensional waves and three-dimensional waves reflect? They do take the wavefront view of waves, but kind of more focused on the rays. So we can actually use rays, and we'll use rays often, just rays, when we talk about light reflection, light refraction. But in reality, it does come from the wavelengths of light, which we don't actually have to draw. But again, page 356, great picture of how a reflection of wave, the wave fronts come off of it and they will bounce off, but we can really map it out with just the rays. And that kind of ties us into the law of reflection, which says that an incident ray and its reflected ray will bounce off at the same angle, okay? Even though these might be like wave fronts that come in, like if these were waves in water and it hits the boundary at a particular angle, then it's going to bounce off at the same angle that it came in at, as measured from the normal. So if this is our surface, this is our wall, this is water, the normal is going to be a good perpendicular line measured to the surface, and it's going to hit right where those rays are going to hit. So this is going to be the incident angle, theta I. This is going to be the reflecting angle, theta R. And the law of reflection says that those two angles have to be at 50. Works in pool as well. So this also works with all sorts of mirrors, like curved mirrors, although we're not going to do a whole lot with curved mirrors. That's one of the things that if you're wanting to take the AP Physics 2 exam, curved mirrors and lenses is something that we just brush by here in IB Physics, but you'll have to do your own self-study if you want to take the AP Physics 2 exam. Strangely enough, we actually do more of that in honors than we do in IB Physics. It's just not part of the curriculum, but it is for honors, so, yeah. And that about does it for today. So, not a whole lot of really deep stuff, which is actually a godsend because I don't think I could go much more. So I'm gonna change the homework schedule. Let's just do 1 through 13 odd problems. There's a good chance I'm not gonna make a quiz. If I feel spunky, I might make one tomorrow, but let's be real, I don't think I'm going to make one. I'm just gonna focus on next lesson. Make sure that I've got a quiz ready for next lesson.
I mean, you have to do the bars.
Yes.
I want to do the pause now, get credit.
So you get extra credit for, oh yeah,
If there's no quiz to replace them.
you said odds, 1 to 13 odds?
Yeah.
Pull up one.
All right.
But what's the next?